We're going to have a look at the mole and exactly how we use the mole in chemistry. The scientists came up with the mole as a way for us to relate different chemicals and different things in chemical formulae. So I'm going to explain the mole ratio to you and how we use it. If we use a simple chemical equation like this, aluminium plus oxygen forms aluminium oxide, I need to go and make sure that this chemical reaction is balanced before I can continue. At the moment, I have 2 oxygens on the left-hand side, as well as 1 aluminium, while on the right-hand side, 2 aluminiums and 3 oxygens. If I look at my oxygens, if I have 2 on the left-hand side and 3 on the right-hand side, the only way I can balance this is if I take both of them to 6. Remember, when we balance chemical equations, we can only add numbers in front of the atoms or the molecules or compounds. So I added 2 in front of aluminium oxide, therefore this gives me 6 oxygens. I added 3 in front of oxygen on the left-hand side to balance it out. On the right-hand side I have 4 aluminiums, and therefore I'm going to add a 4 in front of Al on the left-hand side. And now this is a balanced chemical equation. Now the mole ratio tells me that if I have 4 moles of aluminium, 3 moles of oxygen will react with it to form 2 moles of aluminium oxide. You can imagine this is like saying you have 4 cups of flour and 3 eggs, and when you combine these ingredients, you can bake 2 cakes. Now we all know cake recipes are not that simple, but just to explain the ratio. So this means that for every 4 aluminiums, 3 oxygen diatomic molecules will react with it. This mole ratio is very important. It doesn't mean that we have 4 aluminiums or 3 oxygens. It just tells me in which ratio they are going to react with each other. So let's say, for example, that we go and say that we have 8 moles of aluminium. We want to figure out how many moles of oxygen do we need to form aluminium oxide, and how many moles of aluminium oxide will then form. If I have 8 aluminiums and the mole ratio is 4 to 3, I can go and use this mole ratio to calculate the amount of moles of oxygen that will react with the aluminium. So I'm going to use my mole ratio of 4 to 3, and now instead of having 4 aluminiums I have 8, leaving my amount of oxygen as my unknown, and I assign the letter X to it. Now you can multiply crisscross, and this is going to give you the following values. 4x is going to be equal to 8 times 3, 24. I divide by 4 on both sides because I want x on its own, and this is going to give me a value of 6. So 8 aluminiums will react with 6 molecules of O2. If I then want to go and figure out how many moles of aluminium oxide will form, I can still use this mole ratio recipe. If I have 4 moles of aluminium, 2 moles of aluminium oxide will form. So I'm going to use the mole ratio of 4 to 2. Now earlier you saw me using 4 to 3. I'm going to use the known amount as well as the substance that I'm trying to calculate in my mole ratio. So here my known amount is my aluminium, and the substance that I want to calculate my aluminium oxide. And that's why I'm using 4 to 2 for this last part. Now if I have 8 moles and I make my aluminium oxide my unknown, I multiply crisscross. This is going to give me 4 times x, which gives me 4x being equal to 2 times 8, 16. I divide by 4 on both sides to get rid of any numbers on the left hand side, and x is going to be equal to 4, which means that 4 moles of aluminium oxide can possibly form. We're going to look at how we use this when we don't have moles but we have grams, for example, or volume in another video. So have a look out for that one, and remember to subscribe to the channel so you get all the latest updates and latest videos as well as problem solving.